All right, let's go ahead and get started. So things that we should be aware of upcoming. A week from today, we are going to have our first exam in here. My goal is to get you a brief study guide by the end of the day. I can also start some classes next week with, does anybody have questions about that study guide? The way that I handle study guides for exams is I usually just give you a list of topics. I'm not going to give you practice problems necessarily, just kind of a big list of what we have covered. And when I go through and make the exam, I am pulling questions from those topics. I'm making questions out of those topics. And I make sure there is a tie between a question on the exam and something from the study guide, some of those topics. So you can use that just to make sure, do I understand this idea? Do I know what it is intuitively? Can I apply it to the kinds of problems that I've seen? Can I apply it to kinds of problems that we haven't really seen a ton of, but use that same idea? I do try to put critical thinking on exams whenever I can, so it's not just regurgitation. It will probably be more problem solving than straight regurgitation. So don't just memorize and then hope things are going to be good. Try to get some practice with things like designing good kinds of tests, know the difference between good and bad tests, not just in the examples there, but if you see code that is very different from that, be able to apply those same principles. So that's where my head is with regards to the upcoming exam. It will probably be more like a quiz, just considering we haven't covered a ton of material. And a lot of the asides that I go in class are not part of the actual material for the class. They're just more so, I think this helps make things more intuitive, more clear, but they will not be elements of the study guide. So you do not need to know, for instance, 2's complement representation of binary numbers. As cool and useful as that is, it's not part of advanced OO design or design patterns, which is the purpose of this class. You do not need to know the internal memory structure of objects or the internal memory structure of whether or not, if you have null or a deep copy versus a shallow copy. All of those things are really important to know and may inform some of the topics in class, but you will not see them on the study guide. The only thing that we've really covered so far that is part of this class has been testing. And I'm also not going to introduce a bunch of stuff new next week and then put that on the exam on Friday either. So I'm kind of placing the cutoff at the end of the unit testing slides, which there's one more day of, probably Monday, but that is the cutoff for what should appear on the exam. Does anyone have any questions about anything upcoming or any questions about how to study for the exam or how to prepare yourself at this point, knowing that it's a week out still? All right, I will try to get that study guide to you sometime this afternoon. In the meantime, I know we had some more unit testing that we could do, but I figured why do that when we could instead have a programming practice problem. This one I find to be very fun because it will tie together some ideas that maybe some of you have not seen before. Who here has heard of or knows the fundamental theorem of arithmetic? Or know what that means? As simply as I can put it, it's basically this concept that all numbers can be broken down into a unique set of primes. So if we were to write out some small positive numbers, starting at 2, because we know 2 is prime, 3 is prime, 4 is made up of 2 times 2. Starting to die on me. I've been having too many office hours. No such thing as too many office hours, bro.
Oh, we did this discrete.
Yeah.
Yeah.
5 is prime. 6 is made up of 2 times 3. 7 is prime. 8 is made up of 2 times 2 times 2. But each number is represented by a different product of primes. So you can continue this process for any positive integer, and you can represent it uniquely by a product of primes. So this question is saying, so we can split things down into prime factors. And there may be some repetition of these prime factors, but if you wanted to do prime factorization for a number, you'd end up with this unique sequence. So because of this, there is an algorithm that we can write to be able to find the prime factors of large numbers. And it is actually relatively efficient. So if you don't know your neighbor, introduce yourself to your neighbor. If you know your neighbor, say hi again. Exactly those words, hi again. And start thinking about pair programming. Spend some time trying to figure out what might that algorithm be. How could we construct a reasonable process for finding these prime factors and then being able to isolate the largest prime factor? I'll start to give you hints about this, and we'll start to go over partial solutions for how to construct this in a few minutes, but I want to give you some time to get started first.
So, I mean. We should talk a little less. Yeah. That would just be like the start. Yeah. Next. Yeah.
I think you'll want to write your own. The easiest way to do this is to break it into a subroutine. I think people are starting to figure this out. We need a way of determining what this list of prime numbers is. And so what we need is the ability first to determine, is a number prime? And then we need another subroutine for starting to generate prime numbers, so that we can check, is this a prime factor of the large number? So starting to come up with subroutines. I'm going to call them subroutines. You may call them. These are usually called methods in Java, but subroutines are just kind of these processes that are sub-problems of the problem. So I'm going to call one of them is prime. What would we expect is prime to take as a parameter? Some kind of integer? Is it going to return something? Some kind of Boolean? All right, and then we need to have some kind of sequence or some kind of method that just generates primes. Does generate primes need any parameters?
on what we're gonna have it stop at, because,
Maybe some kind of upper bound.
yeah,
Generate primes up to, but not including. So some int we'll call upper bound. Seems like a good place to start. What should generate primes return? An array of primes. So maybe we have something like an int array. We could solve it that way. Sure. We'll start there. Try to fill in the logic of these subroutines to figure out, given a query, is it prime? Given an upper bound, generate all primes up to that. This probably won't end up being an int array. What should this be instead? Sure. I think that will make your life a little bit easier. If it's an int array, what do you have to worry about? Resizing the array when it fills, when you say something like. You have to give it some kind of size. What if this size is smaller than the number of primes between 2 and the upper bound? We'll need to be checking for that. An array list does that resizing for us underneath the hood. It's good to know exactly how that logic works. And in data structures, you might find yourself implementing an array list. I don't know if that's actually how that works or not. I'm teaching data structures next quarter. There's probably going to be some kind of implementation of your own implementation of an array list in that course. But thinking about how that logic works underneath the hood is very useful for understanding computer science problems. But if you're just trying to solve a problem like this, don't worry about it if you don't have to. Use an array list instead of a primitive int array.
yeah. Yeah.
So you can put that as a.
Although when having the
Signature on that
is
make sure it's as a problem. Then it doesn't have to like all. They
So I need to start with my mom too, so check them.
It's. Doesn't try to figure out just to the sports of the number bank checking.
It makes sense. I don't think there's an easier way to do it. Yeah, so it's. Yeah. That one was wasting time.
Yeah, and I'm pretty sure there is no.
So it's like in general, just gotta put it in box.
So there's another edge case.
Check the arrays and stuff. You just go back for the web and just go. Yeah, it's you just cycle through the arrays, do functional, take something which is worth it. Yeah. That was it.
The date of number. So you could start at point. But that's catchy. So once it's two.
Yeah, let's get like we can reach something to.
Yeah.
It's so good. It's gonna do.
Well, we're still checking.
Do you know, if there's everything zero or?
No, we.
Oh, because it's kind of like it's a word method before you go into innovation. So you need.
I'm not sure it's.
Yeah. And we all right track, but it's just joy.
Yeah.
And you need to help it function first. You need to know if it's not.
Yeah.
Then you can't figure out the volume prime factor. Even multiplication to solve that.
Easy one. We get tested on. Yeah.
Oh my God, that's.
Yeah, well, upper bound would be,
So
whatever that was.
maybe have like
A big. You got this.
I think that would be better.
I
do like it.
There's one.
Making some mysteries, not for this. Like that was for your.
Then
Some-
I would have help method of solving this prime, which is here, right? That's what we're doing is prime. So then we do
And then
is we
we
check each of the stored.
How's your father's name?
So basically, if you need to act, so since it's a dynamic, that's what we can do.
Because then we have to add it.
That's not prime, that's stored,
Yeah.
right? And then after that, the bar, the very end of that, so dynamic is a. That's one that's.
And I think we'll want to use. The argument has to be excellent.
Did you
Want to see that as.
You can.
Actually, the argument.
Yeah, I forgot.
You got your city.
Next thing.
Yeah, you just call it out.
Yeah, you just call them.
With that, but
And then you can do some logic, like, and then, quite almost that, say that.
that would just. Modulo.
You return the array, that's the.
Yeah, I mean, any other suggestion? So.
You need the rest of it. Multiple ways of doing this.
Whichever one.
You're with. That is.
We got 5 minutes where you're not gonna get the internship. You found a Google.
Yes. I love that so much. Yeah. Yeah, I need a plus. I was walking out this way like that, 8 cents load.
Yeah, I work like 6 AM to 10.
On this side, other side.
You go, you make the, it's crazy.
I can't. I don't know.
Okay.
It's not the best, like your tagger. Also. Yeah, I mean, Monday or Tuesday.
I think the goal was on the primaries for a long time.
Monday, Tuesday.
I thought.
Yeah, we really don't. Because one is.
All right, let's talk about getting started here. So
Good at it.
which of these subroutines makes most sense to implement first?
Is prime.
Is prime? Anyone agree with that? We would think that generate primes is going to call is prime, so it'd be nice to have the most central problem solved first, so you're not trying to write logic that has some unimplemented logic that it relies on. So I like to try to think about a program as like a big box. Where is the problem? What is the most outer problem? Well, it's kind of find the largest factor, right? Once we find the largest factor, we're done. So if we could answer this problem, we'd have our answer. So outside is going to be find largest factor. All right, to be able to answer that question, we need to do some work inside of it. So to do that work, we first need to generate a bunch of primes. And if we could generate all of the primes of this query, we could generate all the primes, then we could figure out the largest factor from that. And within generate primes, to be able to generate the primes, we need to figure out is a particular number a prime number or not. So you can kind of draw another internal rectangle that says this logic is going to be inside of generate primes in order to figure out what the primes are that are associated with this large number. First of all, what is this large number? Anybody who can read it?
True.
It's actually only 600 billion. 600 billion, 851,475,143. Seems arbitrary, but that's the whole point of a lot of these Project Euler problems. Just give you some large number and say, do something to it. All right, so if we have this view of the problem, we want to implement it from the inside out. Once we have this logic, we can construct this logic with this piece of the puzzle already complete. Once we have generate primes, we can solve this part of the problem. This should kind of make you think of recursion, or kind of make you think of bottom-up problem solving, where we start with the smallest piece, use that as part for a bigger piece, use that as part for a bigger piece. So let's implement is prime first, then generate primes, and then find largest factor. All right, is prime. Stop going to sleep, I love it. You would think that a setting that says never go to sleep would cause the computer to actually not go to sleep. All right, we're going to take a query, and the goal is to figure out, is the current number prime or not? So the question that I would have for you is, this is probably some kind of a loop, right? We need to loop and check the factors of this number. If it is only divisible by 1 and itself, it is prime. As soon as you find another factor that is not 1 or itself, then we can immediately quit and say this number is not prime. In the worst case, what is the largest number that we would need to consider in order to determine whether or not the number is prime or not?
1/2 the query that you're throwing.
1/2?
1/2.
I'm going to use this, I'm going to give you an example of this query. Let's say it is 100. So you're saying if we go from 1 up to 50 and check all of those numbers, and by 50 we've not found another factor other than 1, we can stop. Who agrees with that? That is correct logic. However, it's the incorrect pick for the highest possible number that we need to consider. Can anyone give me another number that they think is the highest possible number that we need to consider. This is correct, it's just inefficient. It'll give you the right answer.
Take a guess, the largest, the second to the largest from 100, odd number.
Interesting. Incorrect, but interesting. I like the way you think. Any other intuition? If we think about this 100 as being broken up into A times B, that's what it means to have a factor other than one in itself, right? There is some A and B such that the product of that equals the query. If we're going to be looping through this and asking the question about 2 and 3 and 4 and 5 and 6, what is the largest possible value of A or B? Such that when you figured out what that is, you know you've come up with every possible combination. This would be the case if multiplication weren't commutative. Does everyone know what I mean by multiplication being commutative? That means that A times B is equivalent to B times A? Yes, why 10?
Well, because it's the largest will end up being.
Yeah, exactly, it's the square root. So if you think about this 100 and all of the different rectangles that you could draw such that the area of that rectangle were 100, you could have the 1 by 100 rectangle. You could have the 2 by 50 rectangle. And this would continue until you had a 10 by 10 square. Once you have the 10 by 10 square, every shape that you have left to consider is going to just be a rotated version of one of the rectangles that came before it. But since multiplication is commutative, you would have found those factors, like it's the same factors, right? It's just A and B are flipped. The size of the number of rows and the number of columns are just flipped, which means that you would have run across it in its flipped form earlier than that. So you can stop once you reach the square root, because that would generate the square that is every possible rectangle that it could be. That's just one way of thinking of the problem. But to me, that is intuitively why we only have to go up to the square root. So for instance, if we're looking at 100, what are the factors of 100? They come in pairs, right? So we have 1 and 100. We have 2 and 50. Doesn't go in 3 evenly. 4 and 25. 5 and 20. 6 doesn't go in evenly. 7 doesn't go in evenly. 8 doesn't go in evenly. 9 doesn't go in evenly. 10 goes in evenly. And 10. 11 doesn't go in evenly, but actually we can stop now because the only other numbers that are going to go in evenly are the opposites of what we did on the other side. So we would, if we continued past 10, we would get to 20 and 5 and 25 and 4. But the idea is if we reach this point without finding one, then we don't need to look further. We already know it's prime. All right, that's all I wanted to give you as a hint for how we're going to do this. So if we're designing is prime, we only need to loop up to the square root. If at the square root we haven't found it, then we're done. So what is the logic of is prime?
For every int, we can even start with I at 2. And then as long as I is less than or equal to the square root of query, we can increment I, and then just run an if. And it, yeah. And if, query modulus I is equal to 0, then we return false.
Yeah. I agree. This is an excellent implementation of is prime. It doesn't go higher than it needs to, and you can see that the difference between 10 and 50, you're doing 5 times as much work if you're going up to half the value as if you just go up to the square root. Think about how that scales as the numbers get larger and larger and larger. If it becomes something like 600 billion, what is the difference between the square root and half? A lot of repetitions, a lot of unnecessary work that our program is doing. So it's always worth considering, is there a faster, more efficient way to implement this? A lot of the time it's worth the extra effort that you put into thinking about the problem to find that solution.
In this situation, wouldn't it, oh wait, if it's gonna return true, then we'll keep checking.
Yeah. So it's gonna fall out of this loop at the square root of the query. If it falls out of the loop, then we know that it is prime. If it is not, it'll return false. This first time we return false, we're done. We don't have to return false multiple times. It just kills the query and says that it's not prime. We found a factor between 2 and the square root. All right, that's is prime. So the next thing to consider and implement is generate primes. Take a few minutes, see if you can. Now you have is prime. So as you're generating primes, you can call is prime and figure out whether a particular number as you're generating them is prime or not. So what logic needs to surround is prime to generate the associated primes between 1 and some upper bound that represents the last number we need to generate a prime for? So one thing that I'm hearing that may be correct, may be incorrect. If you generate a bunch of primes between 1 and the query, so in our example here, the query was 100. Is the last prime that would be generated the answer? What is the smallest, or the largest prime less than 100? Think it's 97? Is that a factor of 100? No. So there's some additional work that we need to do in find largest factor after we've come up with a list of primes.
I'm sure that. Might be using this problem. No. Generating prime numbers up into the square root. And so we would just do. Mhm.
Have we come up with a reasonable algorithm for determining what the largest prime would be? Like, what would the process be without code necessarily? How would you answer the question? Let's say you have a list of primes in front of you. 2, 3, 5, 7, 11, 13, etc. You just have that list in front of you. How would you figure out what the largest prime factor of that number is?
Go backwards. Start from the largest numbers, check.
I would argue you actually want to do something else. Because you can find a prime factor for something that is not. How do I want to do this? Like we have 8 is 2 times 2 times 2. If you go backwards, I would argue that it's going to end up being more work. You're going to go skip over a bunch of unnecessary primes than if you started at the beginning, because most of these numbers are going to be small. And you can see that even for this massively large 13,195, the largest prime factor is a fairly small number. There are a lot of primes in between 29 and 13,195. So I recommend starting at the low end. But what needs to be done to be able to handle things like this repetition? We know there's a unique combination of these that will give us this query, this number. Let's give you the algorithm. You start with the lowest possible prime, 2, and you ask yourself, does 2 go into the number? In this case, yes, it does. So we are going to divide the number by that. Iteratively now, we're going to check 2 again. Does 2 go into 4? Yes, we're going to divide this by 2. Does 2 go into 2? Yes. When this reaches 1, not 0, when you divide 2 by 2, you get 1. When this number reaches 1, you found that prime sequence. And the last number that you checked was the largest prime factor of that number. So seeing what that would look like with a number like 13,195, you're going to check, does 2 go into 13,195? No, this is even, this is odd, it doesn't go in. There are no factors of 2 in this number. Generate the next prime. Does 3 go into 13,195? It does not. This tells us it doesn't. You can verify that this does not actually go in. So we're going to generate the next prime. Does 5 go in? Yes, it does. So we're going to divide this number by 5. And then we're going to check if the resulting number is still divisible by 5. If it is, we'll repeat that process, dividing it by 5 until we generate the next prime. And we're going to continue to loop this process until our number reaches 1. Once it reaches 1, the last number you divide, last prime that you divided it by is the largest prime. So that's the logic you're going to want to implement in code. Does the process make sense? Start with the lowest prime. Does that go into the number? If so, divide it out. Check it again. You only move on to the next one if the answer is no, the current prime did not go in. So one might argue that generating a huge list of primes might be inefficient here. You don't know which ones you're going to need. So you might want to combine all of this logic and have a current prime number and a way to pass in a current prime number and generate the next prime number. So you might instead want a generate next prime method and then some kind of driver that's going to take the number from the user and then start with the first prime, consistently call generate next prime, generate next prime, generate next prime. And for each prime it generates, you're going to go through this process of attempting to see whether it goes in evenly with the current number. If it does, you divide the current number by the prime, and you're going to loop that process until current number is 1. If you've stored off the last prime that went in, that's what you want to return as your answer. Starting to run out of screen space. So this UB represents the upper bound from the other screen, and I'll call it upper bound for the rest of this, but this should be upper bound. I just want it to be visible to everyone remote. So I'm going to stick with my original and generate an array list. Just because I feel like that will be more intuitive than writing a generate next prime method. It will not be quite as efficient. What is this upper bound? What is the largest possible prime factor of a number? Square root. It's the same logic we had in is prime. If we're going to run into a prime factor that is larger than the square root, we would have run into its pairing factor before the square root. So instead of passing in the upper bound, we could pass in just the query and then say that the upper bound is going to be the square root of the query. That's probably the better way to do it. because if you're writing something like we talked about APIs at the end of the review period, knowing if you make your API that the parameter that it takes is the upper bound, then you're relying on the user to know what that upper bound is supposed to be. You should embed that logic inside of your method such that it takes the number, the query, and then inside of this, you could say int upper bound equals the square root of the query. And that does not force the user to know this logic. That makes way more sense. Question?
Would upper bound have to at least be a double?
Yeah, if we're doing a square root, yeah, you're right, this should be a double. If we wanted to keep this an int, what would we want to do? Since we're gonna want to iterate this up to the upper bound, I actually think we do want to keep this as an int, but that means that we need to do one other thing to this. It should be, yeah, kind of mapped up floor. I guess we want the ceiling because we want to be able to include it if it happens to be an integer. And if you take so let's just quickly surround this with a map.ceil. That's kind of ugly notation. There's a map.ceil around the map.square root. So whatever the next number up happens to be. We're all familiar with math.ceil and math.square root? Know what those do?
I think you still have to pass it.
Yeah, it's quite possible. At this point, we know it should be an integer. So even if you do need to cast this as an int, that should be. Should be fine. All right, now that we know what the upper bound is, what's the logic we need to work through? What do we need to do? Some kind of loop. I'll write it as a for because I think we can. All right, we're gonna start with 2. Going up to the upper bound, we're gonna need to be able to add all of these to some kind of array list that we should probably have made before we went into the loop. It's gonna get gross, sorry. Array list, type integer. Primes equals new array list. Type integer. All right, now inside of this loop, we can ask if is prime I then so now we're just adding every prime up to the square root into this array list and then returning it, which is what the return type that we expect. Ugh, we're out of time. Luckily, find largest factor now, we just have to figure out the process of taking the current number query and feeding it in starting with the first element of this list of primes and just looping that until it doesn't go in, and then moving to the next one, looping until it goes in, stopping when the query is 1, because we're gonna be manipulating the query and dividing it in and dividing it in and dividing it in. And eventually that's going to be 1. When it is 1, the current position in the array list of the last prime that you checked is going to be the largest prime. You can return that number and that will answer the whole question. And this program should generically solve this for any particular number. It doesn't have to be this number, you just get that number from the user, and this should run relatively quickly. So we are unfortunately out of time, so I will leave the find the largest factor for you to implement. If you do it, great. So make sure you submit it to Project Oiler. Question?
Do we get extra credit if we do?
I'll be hesitant to get too much extra credit, but I do think it's absolutely worth doing. So go ahead, and it may be a small amount of extra credit, but I'll give you a little bit of extra credit. If you implement it and send it to me.
We have to like email it.
Yeah, email it to me and I will kind of on a weekly basis just check these, and I'll make an extra credit section on Canvas where you just get, there are a bunch of assignments that are out of 0, and whatever you implement, you'll get some credit for.
And do you want this, like, you want to submit itself, or like, pictures of,
Yeah, submit the code itself so that I can run it and check it.
Okay.
And if you're really feeling,
Yeah, it's gonna be.
if you're really feeling it, write some tests for this to ensure that it works. And that's, yeah, I'll give you some extra credit if you write some tests for it. And that'll be a way of practicing writing tests before, ahead of your.
Challenge accepted.
Yes.
Sweet.
I'm gonna do it.
Yeah, when I was sweet.
Right? You know why I chose stack for this problem? Because at the very end, my stack on the very peak, it's gonna be down. So I can just pop out the ones I don't need,
Yeah,
push the ones that I need to check, and then peek the
Makes sense. That makes a lot of sense.
I don't putting more labor.
You guys are.
All right, thanks everyone remotely. If you have any questions, so kind of drop them in chat, so I clean up and I'll.
It's gonna be down there. I don't know.
If you have any questions.
Oh, shit.
I think you want to, thank you.
Yesterday, I was shoveling snow. It was, I felt so intensively, I blocked my whole really big driveway within 20 minutes, so I was like, no, I'm suffering with that.
20 minutes to do it. It takes me like an hour to shovel sometimes.
It sounds like.